in this class, we are going to discuss module 4 is symmetric matrices and quadratic forms. Now, first in this class, we are going to discuss how to diagonalize the given matrix. Now, I am going to explain in this class. Okay. Now, before going to take how to diagonalize the matrix, first I have to recall your basic concept. I to need to study for diagonalization. What are the prerequisites is required? I am going to discuss for hardly 5 minutes. Now, first I need diagonal matrix. You know what's the meaning of diagonal matrix. In the matrix must be a square matrix except principal diagonal, the rest of the values are 0. Say 1, 2, 3, the rest of the values are 0. Now we treated this is an what type of matrix? Diagonal matrix. Except principal diagonal, rest of the above and below of the principal diagonal values are 0. Then we consider that matrix as a diagonal matrix. And also I need symmetric matrix. You know when we treated the given matrix as symmetric matrix. Suppose once you take the matrix, you take the transpose of that matrix, we get the same matrix, we treated the matrix as symmetric matrix. Say for example, I am going to take symmetric matrix is what actually 1, 0, 0, minus 3. You take the transpose of this matrix. What is the transpose of this matrix? 1, 0, 0, minus 3. Therefore, both are must be same. Once you take transpose means convert the row into column, we get the given matrix, then we say that a matrix is a symmetric matrix. Apart from that, we need to know that how to find out the eigenvalues and eigenvector. You already studied in second PUC and also you studied in first year B level. Then apart from that, I have to recall that how to find out eigenvalues and eigenvectors. Suppose you have a matrix. How to find out the eigenvalues and eigenvectors? Now, first you take a determinant of A minus lambda I, where lambda is some parameter. Now, you have to, A is a given matrix, I is an identity matrix. Order of the identity matrix is same as order of the matrix A. Take the difference of the determinant equal to 0. Then you solve this determinant, we get a characteristic equation. Is a polynomial in terms of lambda we get. That is called the characteristic equation. You find out characteristic equation from determinant of A minus lambda I equal to 0. Now we get a characteristic equation, we get a equation in terms of lambda, we get a polynomial in terms of lambda. The degree of the polynomial depends upon the order of the matrix. Suppose it's a 3 cross 3 matrix. After you evaluate this determinant of A minus lambda I, we get a polynomial of degree 3. Therefore, polynomial degree is equivalent to the degree order of the corresponding given matrix. Once we get a polynomial, use your VTU allowed calculator. You find out the roots of the polynomial or using any fundamental method, find out the roots. Lambda 1, lambda 2, lambda 3 like that. Suppose it's a 3 cross 3, we are expecting 3 roots. Once we get 3 roots, next you find out these are the eigenvalues. These are the what we get, the roots are called eigenvalues. Once we get eigenvalues and then you find out the corresponding eigenvector. How to find out the eigenvector? You take A minus, this is square bracket is denotes matrix. This is determinant. So, matrix of A minus lambda I into X. X is a number of unknowns or unknowns is a column, I'll tell you, equal to 0. A is a given matrix, lambda is you know that, and I is identity matrix, it depends upon the order of the matrix A. So, you see, whenever I write it in the square bracket, that stands for matrix. Absolute sign is determinant into X. X is a column matrix, is involve unknowns, depends upon order of the matrix. Suppose is the order of matrix is 3, our X matrix is nothing but x1, x2, x3. Now, you take one by one lambda value, take lambda is equal to lambda 1. Yeah, you frame this, we get a system of equation. You take two independent equations, find out the values of x1, x2, x3. We get x1, x2, x3 is a corresponding lambda 1 eigenvector. Similarly, take second lambda 2 substitute, we get a system of equation. take it out of 3, take it 2 independent equations, solve that, you find out x1, x2, x3. That is another eigenvector. Like that you get 3 eigenvectors. This is a way I to find out eigenvalues and eigenvectors. Even though you studied already basics things, I repeat it once again. This is a way I to find out eigenvalues and eigenvectors. These things are required while studying diagonalization. That's why I recall the fundamental things. Now let us move to diagonalization form. Okay, fine. See, while doing diagonalization, first you observe the matrix. Suppose the given matrix is a symmetric, means A is equal to A transpose. Now, diagonalization formula is D is equal to P transpose A into P. Yeah, keep in mind the matrix is symmetric. A is equal to A transpose. Suppose the matrix is symmetric, usually that matrix is a symmetric matrix. Then what is my diagonal formula? Diagonalization means except principal diagonal, rest of the values are 0, and also the principal diagonal values are nothing but the eigenvalues of the corresponding matrix. Suppose the eigenvalues of the matrix A is 1, 4, 5. Once you use this formula, diagonalizes, we get a diagonal matrix. In the diagonal, we are expecting eigenvalues of the matrix A. Therefore, what is D? P transpose A into P. P transpose A into P. This is a formula to find out, I to diagonalize the given matrix. Suppose the matrix is a symmetric. Suppose A is not a symmetric matrix. In that case, we are doing the diagonalization formula is P inverse A into P. P inverse A into P. This is a formula for what about diagonalization. Suppose A is not a symmetric. In this case, how I to find out P? Suppose A is a symmetric matrix, given matrix is symmetric matrix, what's the formula written to diagonalize the matrix? P transpose A into P. P is nothing but the columns of the matrix P is nothing but orthogonalized, orthonormalized vectors of A. You know that in the module 3, how to find out orthonormalized vectors. Here also we find out orthonormalized vectors of the given matrix is nothing but the column of P. You pick the each column of the matrix, you calculate. You see, you have to normalize the vector. You see, I am explaining how to do the normalization. You can't do like that module 3. Now, P transpose A into P. What is P is nothing but my, what about that? P is nothing but my orthogonal normalized eigenvectors. Normalized eigenvectors, sorry. What is P is nothing but the columns of P is nothing but normalized eigenvectors. Normalize orthogonal vectors. Yeah, how to find out orthogonal vectors? I am explaining, not for using Gram-Schmidt process. We are using different method. Yeah, this P is nothing but the columns of P is nothing but normalized orthogonal set of vectors of given matrix. But here we can't do like that. I'll explain while doing problem how to proceed, how to take P, how to find out P inverse. But keep in mind, whenever the matrix is symmetric, this is a formula for to diagonalize, this is a formula for non-symmetric. Now I'm going to take one problem based on that. First one, I'm going to take a first one. The problem is, yeah, diagonalize for the matrix, okay, A equals, okay, minus 6, minus 2, minus 1, minus 2, 6, minus 1, minus 1, minus 1 and 5. Minus 6, not minus 6, sorry, 6, 6, minus 2, minus 1, minus 2, 6, minus 1, minus 1, minus 1, 5. Okay. This is a given matrix. First, I have to verify whether A transpose equal to A. Take the transpose, means A transpose is nothing but 6 minus 2 minus 1 minus 2 6 minus 1. Okay. What is the next one? Minus 1 minus 1 is 5. Therefore, this is must be equal to what? A. This is must be equal to A only. Therefore, the given matrix is a symmetric matrix. It's a symmetric matrix. How to diagonalize? The formula for D is nothing but P transpose A into P. First, you find out P. I told P is nothing but normalized normalize of orthogonal set of vectors of the given matrix. What's the given matrix here? A. How to find out that vectors? Now here, first you find out the eigenvalues of this given matrix. What's the how to find out eigenvalues? A minus lambda I must be equal to 0. What is my A? A is a given matrix. What's A is a matrix is this lambda I. What is my lambda I is nothing but lambda into I is what? 1 0 0 0 1 0 0 0 1. Yeah, you subtract it. What is A? 6 minus lambda. The rest of the values as itself because only diagonal values are vary. Minus 2, 6 minus lambda minus 1 and then minus 1 minus 1 5 minus lambda determinant of this. You know how to evaluate this determinant. Now you take plus 3 cross 3 determinant plus minus plus. How to evaluate 6 minus lambda means occur in first row first column of neglect that you take the remaining 6 product of determinant of this value 6 minus lambda into 5 minus lambda minus of up once you go for upper arrow take minus of again you have minus into minus plus 1 you have minus of minus 1 into minus 1 we get 1 minus 2 you have but middle value always I take minus sign here plus minus into minus plus 2 of leave first row second column take this and this take the multiplication minus 2 into 5 minus lambda minus of minus into minus what we get plus of 1 okay and also last value minus 1 plus sign we get plus into minus is minus 1 into leave first row and last column take the rest of this these two this minus into minus plus 2 minus of we have minus we get plus 6 minus lambda equal to 0. This is way we have to evaluate that determinant. You simplify that, multiply and simplify that. Finally, I am writing final answer because I am not going to simplify on the board. Now, after the simplification, we get a polynomial. The values of lambda is equal to 3, lambda is equal to 6 and lambda is equal to 8. We get these three values. I am written directly these values. You know the method simplify, we get a cubic polynomial. After the simplification, you get a cubic, because what's the order of the matrix? 3. Therefore, what's a polynomial degree you are expecting? 3. Therefore, it's a cubic polynomial. Therefore, now I have to evaluate. Finally, we get after, I leave this in between the steps because it's a basic thing. Simplify, we get a cubic polynomial and further simplify, we get these three are the roots. Once we get these roots, I have to find out the corresponding eigenvalues. Now, first you take the matrix form I told. What's a matrix form I told? Matrix of AX A minus lambda I into matrix of X must be equal to 0. Yeah, what is my A? You know that A minus lambda I just now I written that is a thing 6 minus lambda this is a matrix minus 2 minus 1 okay and minus 2 6 minus lambda and then you have to take minus 1 okay fine and then minus 1 minus 1 5 minus lambda is a matrix of what is that x1 x2 x3 okay fine it's nothing but 0 yeah. 0 can also be written as 0 column matrix. Now, this is our a formula for finding eigenvectors. These are the eigenvalues. I have to find out eigenvector. Take first, this, I am taking this as star. Okay. Now, I'll put lambda is equal to 3 in star. Put lambda is equal to 3 in star. Yeah, in star, that implies, yeah, put lambda is equal to 3, what happens? 6 minus 3, 3, minus 2, minus 1. Minus 2, again we get 3, minus 1, minus 1, minus 1, 5 minus 3 is what? 2. Okay. x1, x2, x3. 0 can also be written as 0, 0, 0. Now I have to multiply. After the multiplication, equate both the sides, row into column. What we get finally? Equation 3x1 minus 2x2, yes, and then minus x3, x3 equal to 0 is a one equation, minus 2x1 plus 3x2 minus x3 equal to 0, okay. And also I have to take minus x1 minus x2 plus 2x2, x3 must be equal to 0. I think everyone is clear. Multiply this, we get a column matrix. Once we get a column matrix and equal to right hand side, two matrices are equal means what? Corresponding components are equal. This comes in 1. Yeah, we get like that. After multiplication, we get like that. This is equal to 0, 0, like that. We get. And then equate that. What I written the board, we get. Equal to that, we get 0, 0, 0. You choose any two independent equation. I'll choose first two equations because both the equations are independent. Means first equation cannot be expressed in terms of second, or second cannot be expressed first. Now both are not same also. Therefore, they both are independent equations. Now both are independent equations. You solve these two equations and then find out the values. X1 divided by, yeah, leave this, you take the remaining quotient. Just like a cross multiplication, minus 2 into minus 1 is 2. Minus, you taking upper arrow minus, minus of 3 into minus 1, minus 3, we get plus minus of minus 3, okay, equal, always middle one is negative minus x2 divided by, leave this, you take the first and last, 3 into minus 1 minus 3, minus of minus 2 into minus 1 is 2. Yes, we get must be equal to x3 divided by, leave last column, then you take first and second, 3 into 3 is 9, minus of minus into minus plus 2 plus 4, we get 4. Then you simplify this, what we get? X1 by 5, correct? X2 by 5 and x3 by 5. That implies x1 by 1 because it's a common, x2 by 1, x3 by 1. Therefore, the corresponding one vector is nothing but what actually? 1, 1, 1 is the one of the vector. Capital X1 is a one of the vector of lambda is equal to 3. Similarly, find out other two vectors. Yeah. Similarly, find out other two vectors. Yeah. Now I have to take, put lambda is equal to 6 in star. What we get? Lambda is equal to 6. 6 minus 6, we get actually, we get 0. 6 minus 6, you put lambda is equal to 3 and then put lambda is equal to 6. 6 minus 6 is 0. Minus 2, minus 1, minus 2, 0, minus 1 and then minus 1, minus 1. 6 minus 5 minus 6 is minus 1. Okay. X1, x2, x3. You take it and then observe carefully. This must be equal to 0. 0 can also be written as 0 column. Then you simplify that, minus 2x1 minus 2x1 is 0. Therefore, minus 2x2 minus x3 equal to 0. Minus 2x1 minus x3 equal to 0. Minus x1 minus x2 minus x3 equal to 0. Therefore, what I am going to do, instead of taking these two, I am taking these two. Why? Because in the last equation involving all the three, x1, x2, x3. Now, I choose these two, B and C. From the B and C, while taking B and C, which one is 0? I am rewriting in the correct form, minus 2x1, which term is 0, x term is 0. Therefore, I will write it 0 into x2 minus x3 equal to 0. Next is minus x1 minus x2 minus x3 equal to 0. Now, from these two, I am going to write what is my x1. x1 divided by 0 minus of minus 1 into minus 1 is 1 we get, okay, must be equal to minus x2 divided by minus 2 into minus 1, first and last column, 2 minus of minus into minus plus 1 we get 1, and then what we get, x3 is first two columns, minus 2 into minus 1 is 2, again you go upper arrow minus of 0 because you are having 0, okay. Now, see, we have to simplify further, what we get, x3 by minus 1, x1 by minus 1, x2 by 1, and 2 minus 1 we get minus 1, 2 minus 1, 1 numerator having this x3 divided by 2, yeah, x3 by 2. Therefore, from this, what is my corresponding eigenvector? Minus 1 and 2 is the eigenvector. I explain why you choose last two. Similarly, take lambda is equal to 8. We get another eigenvector. Okay. Lambda is equal to 8 in star. What we get actually? Minus 2 because 6 minus 8 minus 2 minus 1 minus 2, again this is minus 2 minus 1 minus 1 minus 1 minus 3 because lambda is equal to 8, 5 minus 8 is minus 3 into x1 x2 x3. This must be equal to 0. 0 can also be written 0 0. Now, we have to simplify that, minus 2x1 minus 2x2 minus x3 equal to 0. Minus 2x1 minus 2x2 minus x3 equal to 0. Last equation, minus x1 minus x2 minus 3x3 equal to 0. Now, observe these two equations are same. We can't take first two equations because both are same. Therefore, I will choose the last two equations. From the last two equations, I have to find out x1, means leave this column, take the rest of things, 6 minus of minus into minus plus 1, we get 6 minus 1. Yes, must be equal to minus x2 divided by, leave this column, take first and last column, minus into minus plus 6 minus of, what we get actually here we get 6 minus 1 because 1 minus 1 into minus 1 is 1. x3 divided by first two columns of the last two equation. Minus 2 minus 1 is 2 minus of minus 1 into minus 2, what we get is 2. Now, I have to simplify that, what we get, x1 by 5, x2 by 5 and here minus 5 actually equal to x3 by 0 we get. Okay. Now, if we want to simplify further, we get x1 by 1, x2 by minus 1 because 5 is a common, x3 by 0. Therefore, what is my third vector is 1 minus 1, 0 is my third vector. Therefore, I am going to write these three vectors on the board. These are the eigenvectors we find out by using traditional method, what you studied in PU level. What is my x1? x1 just now we calculated 1 1 1. What is capital x2 is nothing but minus 1 and 2 is my eigen vector. You just a few minutes before I calculated what is my x3 is nothing but 1 minus 1 0 is my x3, okay, 1 minus 1 0. Now, these are the eigenvectors are calculated tradition method. You are finding eigenvalues and then finding corresponding eigenvector. Now, we have to verify whether these eigenvectors are orthogonal or not. How to verify? Inner product of this. All are columns, they taken x1, take it x1 transpose into x2. What is x1? 1 1 1 into x2, sorry, take it a row 1 1 1 and then minus 1 is 2. What we get actually? Minus 1 is minus 2 minus 2. What we get actually? minus 1 plus 2, we get 0. Similarly, take inner product of x1 comma x3. I have to find out whether it's orthogonal or not. What is that? x1 transpose into x3. What is x1 transpose? 1, 1, 1. And x3. What is x3 here? 1 minus 1, 0. Okay. What we get actually? 1 minus 1 plus 0. What we get is 0 only. Now, inner product of x1 comma x2 comma x3 I have to calculate. What is inner product of x2 comma x3 is x2 transpose of x3. Okay. What is x2 transpose? x2 is nothing but minus 1, 2 and 1 minus 1, 0. Okay. Now multiply that minus 1 minus into minus plus 1, this is 0, we get 0. This shows that therefore x1 comma x2 comma x3 are is an orthogonal set of non-zero vectors. Yeah, once we get orthogonal set of non-zero vectors, next you have to normalize. You know that these are the orthogonal set of non-zero vectors, this form a orthogonal basis. From that is possible to find out orthonormal basis. Therefore, what we are going to do in the next step, we have to normalize these vectors. We have to normalize these vectors. Yeah, means u1 must be equal to x1 divided by norm of x1, u2 divided by x2 divided, u is equal to norm x2 divided by norm of x2, and then u3 is nothing but what? x3 divided by norm of x3. Okay. Next is I have to find out what's the norm of x1. We have x1, right? Norm of x1, you know that is square root of inner what is that? Inner product of x1 comma x1. That is nothing but square root of x1 transpose into x1. Means you already know that I am taking directly 1 square plus 1 square plus 1 square. What do we get? 3. Root 3. Similarly, I have to find out what's the norm of x2. Square root of inner product of x2 comma x2 is nothing but square root of square of each of the value. 1 square minus 1 square plus minus 1 square plus 2 square. 1 plus 1 plus 4. We get 6. And also find out norm of x3 is nothing but square root of inner product of x3 comma x3. What is inner product of x3 comma x3 is 1 square minus 1 square, we get 2 root. Yes, these are the values. We know that 1 by root 3, another root 6 and root 2. Okay. From that we have to find out what is u1. What is u1? Yeah, x1 divided by what actually? Root 3. Means 1 by root 3, 1 by root 3, 1 by root 3. Okay. And also take u2. u2 is nothing but minus 1 by 2 means divided by root 6. 1 by root 6 minus 1 by root 6 minus 1 by root 6 and 2 by root 6. u3. u3 is what? This is x3 divided by root 2. 1 by root 2 minus 1 by root 2 and 0. Okay, fine. These are the values for what actually? u1, u2, u3. From that, I make a P. What is P? u1 is a first column, u2 is a second column, like that. 1 by root 3, 1 by root 3, 1 by root 3. Okay. Minus 1 by root 6, minus 1 by root 6, 2 by root 6. 1 by root 2, minus 1 by root 2 and 0. This is my P value. Yes. Once we get P, now this is what the given matrix is a symmetric matrix. What's the formula for D? D is nothing but P transpose into A into P. Okay. P transpose A into P. Therefore, what I am going to do here, now I will keep P transpose as itself. P transpose, okay. Because at a time you can't multiply more than 2 matrices. Only possibility is 2. Therefore, first you substitute A. What is my A here? 6 minus 2 minus 1. Minus 2, 6 minus 1, minus 1, minus 1 and 5 into P. P just now we written 1 by root 3, 1 by root 3, 1 by root 3. What is second row? 1 by root 6, minus 1 by root 6, minus 1 by root 6 and 2 by root 6. What is the thing? 1 by root 2, minus 1 by root 2 and then 0. Okay. While doing multiplication, now I am substitute P transpose. P transpose means row becomes column. 1 by root 3, minus 1 by root 6 and 1 by root 2. 1 by root 3, minus 1 by root 6, minus 1 by root 2. What is the next? 1 by root 3, 2 by root 6 and then 0. Okay, fine. Half. Multiply this row into column. Row into column. 6 by root 3, minus 2 by root 3, minus 1 by root 3. 6 minus 2 minus 1 is minus 3. 6 minus 3 is 3 by root 3. 3 by root 3. Yeah, I'm doing orally because very simple. Multiply row into column. 6 by minus 6 by root 6, minus 2 by root 6, minus 2 by root 6. We get minus, what about that, 6 by root 6. Why? Because now see, observe carefully, minus 6 by root 6, minus into minus plus root 2 by root 6, minus 2 by root 6, plus 2 by root 6, minus 2 by root 6 cancel. What's the remaining? Minus 6 by root 6 remaining. Next, move to the last column. 6 by root 6, root 2, minus into minus plus, we get 4 by 6 by root 2, minus into minus plus 2 by root is 8 by root. Okay. Next, move to the second row. Minus 2 by root 3, 6 by root 3, minus, we get 3 by root 3. Yeah, 3 by root 3. And the next, the value is, yeah, minus into minus plus 2 by root 6, minus 6 by root 6, and then minus 2 by root 6, we get 6 by root 6 is the value, minus 6, because multiplied this, minus into minus plus 2, here minus 2 is cancelled, we get minus 6 by root 6. Okay. Next, move to the last column, minus 2 by root 2, minus 6 by root 2, we get minus 8 by root 2. Okay. Move to the last column. In the last column, this is 5 actually, yeah, last row with all the columns. Last row with all the columns is minus 1 by root 3, minus 1 by root 3, we get minus 2 by root 3 plus 5, means 3 by root 3. Okay. And then multiplied with this with the second column, minus into minus plus 1 by root 6, plus 1 by root 6, we get 2 by root 6, plus 10, we get 12 by root 6. Okay. And then you multiplied with the last column, minus into minus plus, these two are cancelled, we get 0. We get 0. Okay. Once we get 0, then you multiplied with this to this, row into again column. Yeah. Now 3 by 3 is 1, and then 3 by 3 is 1 and 3 by 3 is 1. 1 plus 1 plus 1, 3. 3. Please try to understand. Root 3 into root 3 is 3. 3 by 3, 1. Again same thing. 1. Again same thing. 1 plus 1 plus 1 is 3. Yeah. Next, first row with second column. Minus 6 by root 18, minus 6 by root 18 plus 12 by root 18. What we get? 12, what about minus 12 plus 12 is cancelled, we get 0. Yeah, I'll doing orally, please do it because it's, you know how to multiply. Take the last row, first row with last column. 8 by root 6 minus 8 by root 6, we get 0, last value 0. And next row, second row with first column, minus 3 by 18 root 18, minus 3 by root 18, and then plus 6 by root 18. Minus 3 is minus 6, plus 6, we get 0. Next, move to the second column, minus into minus plus, 6 by 6 is 1, and then I have to take this minus into minus plus, 6 by 6 1, we get 2, and then multiply that 6 24, means 1 plus 1 2, 24 by 6 is 4, we get 6. Last column with the second row. Here, minus 8 by root 12, minus into minus plus 8 by root 12, plus 8 minus 8 cancel. The last value multiplied with this 0. Move to the last one. 3 by root 6 minus 3 by root 6 and then plus 0, we get 0. And then second column with last row, minus 6 by root 12 plus 6 by root 12 and then last value 0, plus 12 minus 12 is 0, by 6 by root 12 is 0. Then because first value is minus 6 by root 12, second value is plus 6 by root 12, last value 0. You move to the last row with last column. 8 by 2, we get 4, okay. And next 8 by 2 is 4. Next is minus into minus plus 8 by 2. What we get is 4, yes. And then what's you see, observe 8. See, observe 1 by root 2 into 8 by root 2. Root 2 means 2. 8 by 2 is 4. Again we get another also 4, 8. Last value 0, we get 8. Now you already calculate what is lambda 1 is 3, lambda 2 is equal to 6, lambda 3 is 8. Now I told it's reduced to diagonalize. We accept principal diagonal, the rest of the values are 0, and also in the principal diagonal we are expecting what type of values? Eigenvalues of the corresponding matrix. What are the eigenvalues? Is 3, 6 and 8. Now please try to understand this. This is a way I have to do the diagonalization. Now before going to taking next problem, please try to understand one point is how to do the diagonalization. Diagonalization is a one, before going to start that, observe carefully. This is what type of thing, whether it's a symmetric or non-symmetric. Is a symmetric matrix, how to diagonalize? Using the formula P transpose A into P. First you find out P value. How to find out the P value? Take the given matrix, find out the eigenvalues and eigenvectors using traditional form. Verify what we get eigenvectors are is a set of orthogonal set of non-zero vectors. Now that form a orthogonal basis. Then you have to normalized. We get u1, u2, u3. You replace it, u1, u2, u3 is the column of P. Transpose, you know that row into column. Multiply that, automatically is reduced to a diagonal matrix whose principal diagonal values are entries are nothing but eigenvalues of the corresponding given matrix. This is a way I have to do diagonalize. Suppose the matrix is symmetric. Now I move to non-diagonal, what about the matrix, okay. Is the next problem. Yeah, I move to the next type problem. You please refer my notes. I'm going to share it notes. I have worked more than that. Please work it out based on that notes. Okay. Yeah. Before going to take non-symmetric matrix, I want to share one thing. Now, not only in some problem they are asking to diagonalize, they are going to ask to find out a power of 6, a power of 8, like that. Now, they are asking to find diagonalize and find the values of a power of 6, a power of 8. Now, a power of n must be equal to P into D power of n into P transpose. The condition A is symmetric matrix. A is symmetric matrix. If we want to find a power of n is non-symmetric, the formula is P into D power of n, D power of n into P power of P inverse. You can't take this. A is not a, is non-symmetric matrix. Okay. Yeah. Some case the diagonalize the matrix and also find the a power of 6, a power of 8, like that. There we are using this one. Yeah. Keep in mind. Now diagonal, symmetric, what's the formula to find out a power of 6, a power of 8? What's the formula for finding non-symmetric matrix? Keep in mind. Now based on that, I am going to take one problem. Okay. diagonalize the matrix A equals 1, 3, 2, minus 1, 2, 1, 4, minus 1, 1, and also find A power of 4. And also find A power of 4. Is it clear? Now here I want to find out A power of 4. How to find out A power of 4 here? That's a very, very important. Now the solution. Finding A power of 4 is different. First you verify whether A transpose is equal to A. Is 1, minus 1, 4, 3, 2, minus 1, 2, 1, 1. Is not equal to A, right? It's not a symmetric matrix. It's a non-symmetric. How to diagonalize? The formula for diagonalize is P inverse A into P. The next question is how to find out P. As usual, you find out eigenvalues and eigenvectors. Determinant of A minus lambda I. Use this formula. I already explained in the previous problem, therefore I am not going to do once again. Using same method what I told tradition method, use equal to 0, use that, you find out the eigenvalues. Is a 3 cross 3, definitely you get a polynomial of lambda of degree 3. Now solve that, we get the eigenvalues are lambda 1 is equal to 1, lambda 2 is equal to minus 2, and lambda 3 is equal to 3. These are the eigenvalues we get. After we get eigenvalues, use this matrix, is already explained in the previous problem, and then find out the corresponding eigenvector. For lambda 1 is equal to 1, the eigenvector is nothing but, I am going to write it here, what's the eigen vector for lambda is equal to 1. Lambda is equal to 1, the eigenvector is x1 is minus 1, 4 and 1 is the eigenvector. I already explained how we get using this formula, that's why I am taking directly. And also for lambda 2 is equal to minus 2, the eigenvector corresponding lambda is equal to minus 2, the eigenvector is x2 is nothing but 1, 1, minus 1 and 1. And also lambda 3 is equal to 3, the corresponding eigenvector x3 is nothing but, yeah, we calculated, we get 1, 2, 1. You please do it, this part is already explained in the previous problem. These are the eigenvector we get after substituting the lambda value for 1, minus 2 and 3. Once we get the eigenvector, don't verify whether it's orthogonal or not, because it's definitely is not orthogonal. Therefore, what we are going to do here, you take it directly P. The first column of P is nothing but x1, second column of P is nothing but x2 and x3. Therefore, what is P1? X1, minus 1, 4, 1. What is x2? 1, minus 1 and 1. What is my x3? 1, 2, 1. These are the, this is a way I have to frame my, what about that, this P value. Just a minute, x2, yeah. Instead of this, yeah, minus 1, sorry. This x2 value is 1, minus 1, minus 1. Yeah, after substituting lambda 2 is minus 2. Yeah, this is value is nothing but minus 1. Okay, fine. Yeah. Now this is a way I have to frame P. P is nothing but eigenvectors is nothing but columns of P. Suppose matrix is not symmetric. Next, I want to find out P inverse. P inverse, I want to find out the formula is, you take this matrix minus 1, 1, 1, 4, minus 1, 2, 1, minus 1, 1, put a bifurcation line, you take identity matrix. You go for Gauss-Jordan method, that's all. What's identity? Order of identity matrix depends upon order 1, 0, 0, 0, 1, 0, 0, 0, 1. Use elementary row operation. I am not going to do that part also. You know how to apply elementary row operations. Use elementary row operation. Now I am going to share my notes. In the notes already I did every step. What we are using, use elementary row operations. You convert this matrix into Row reduced echelon form. Row reduced echelon form. Row reduced echelon form means here we are expecting identity matrix, where in A place, P place, we are expecting identity matrix. Once you convert identity matrix using elementary row operation, we convert to row reduced echelon form. Row reduced echelon form means you convert this matrix into identity. While doing that, we get a new matrix in this identity matrix place. That matrix we get minus 1 by 6, 1 by 3, minus 1 by 2, okay, and also minus, 1 by 3, 1 by 3, minus 1, 1 by 2, 0, 1 by 2. Okay, this is our matrix. Yeah. Now what we get instead of identity matrix, that is our P inverse. That is our P inverse. Yeah. Therefore, what is P inverse here? P inverse, we are finding P inverse using this. What is my P inverse is nothing but minus 1 by 6, 1 by 3, minus 1 by 2, 1 by 3, 1 by 3, minus 1, 1 by 2, 0, 1 by 2 have. Okay. P inverse. Yeah, I'm going to repeat once again. This is a non-symmetric matrix. What I did, I've just finding eigenvector. I replace each of the eigenvectors is a columns of P. Next, I want to find out P inverse using Gauss-Jordan method. Take P and then bifurcation line, you take identity matrix. Order of the identity matrix is same as order of P. Using elementary row operation, you convert this P matrix is identity. While doing that operation, we get this new matrix, that is our P inverse. Once we get P inverse, what's our next step? D is nothing but P inverse A into P. You multiply. You know A, you know P, you know P inverse, definitely we get this. Because already I done this, I am taking directly 1, 0, 0, 0, minus 2, 0, 0, 0, 3. Because you already know that how to do the multiplication. That's why I am skipping that step. Because it's very simple. You know P inverse, you know A, you know P. First substitute A and P, multiplied with P inverse value. Definitely is convert diagonal, where principal diagonal values having eigenvalues of the corresponding matrix A of the given matrix. Next, I want to find out A power of 4. Now, what is A power of n formula? I told is just few minutes before. Is a formula for non-symmetric, means P into D power of n into P inverse. You have D, no? What we are expecting here, A power of 4. What is A power of 4? P into D power of 4 into P inverse. Therefore, first you find out D power of 4. D power of 4, D you know that. This is my D. 1 to the power of 4 is 1. What is minus 2 to the power of 4? 16. 0. What is 3 to the power of 4 is 81. Yeah, this is easy. D power of 4 means just you take diagonal values to the power of 4. That gives us D power of 4. Okay. You have D power of 4. Yeah, you have P. You have P inverse. First you multiply D power of 4, this value with P inverse, and then multiplied with P. Then multiplied with B. We get finally A power of 4 is nothing but 46, 75, 35. I am writing in the column form. 5 minus 4, 5, and also 25, 95 and 56. This is our A power of 4 value. Instead of simply multiplying 4 times, this is another way. They are going to ask this type of problem also. And also find A power of 4. What is A power of 4 value? A power of 4 is equal to P into D power of 4 P inverse. See, instead of finding this is easy because except diagonal, rest of the values are 0 in D. To the power of 4 is D power of 4. Same thing they are going to ask where in the matrix is symmetric. Matrix is symmetric, how to do the diagonalize I explained. They are going to ask the find out D power of, find out A power of I, like that. Their formula is P, what's the formula there? P into D power of n into P transpose, that's all. Instead of P inverse, what we are going to take? P inverse. Instead of P inverse, what we are going to take? P transpose, that's all. Yeah, P transpose. This is a thing we have to remember. See, you remember the way is to finding a power of 4, a power of I is after the diagonalize. Suppose use P transpose while doing D value, you take P transpose. Suppose use P inverse means you take finding a power of I, a power of phi using P inverse, that's all. Now I explain one problem based on non-symmetric, I explain one problem based on symmetric. Similar, I am going to share the notes, you refer it and do it. Maybe get idea how to solve that, okay. I'll now in the next class I'm going to explain other topics. Thank you.